So hello everybody. My name is Thiago Macieira. I work for Intel, so you had one Intel session now. Before me was me again, and apparently Hans is talking again. So this week there's a lot of Intel here. I'm in the open source. I've been an open source developer for a long time, and now I've been becoming the technology center. I'm living in Portland, working mostly with open source, and my work is really working on Qt. So I've been around C++ for what, almost all of those 15 years. I think I started in C, and I was only coding in C, and then eventually when I started working on Qt, I started C++, and don't want to go back. When I was coding on C, it's like, why can't you just run some destructors from me? And I've been around open source. Mark?
Yeah, I basically have the same detail. I also was socialized with C++ and Qt in KD, in the framework. A bit less than Thiago, younger. I just worked over a decade, so I have to update it every year. I'm senior software engineer, trainer, and consultant at Qt5, your booth outside, and we are basically focusing on Qt or things Qt. That's the marketing. I recently became the maintainer of the widgets module in Qt, and he is the maintainer of core and debug bindings. Yeah, and I run a blog, at least I did until last year. This year hasn't been a bit busy, so I haven't been creating much content on that. But there's some code from which is searching and C++ and you'll find it.
Okay, yeah. So just quick show of hands. Who has before used Qt in this room? Okay, good. Just good to know. And Qt5, how many people have looked at it yet? Okay, no, so it's fine. Right. So just show what it is. Qt5 is the first major version in 7 years. You might not remember, but Qt 4.0 came out in 2005. So it's a long time. We've been working on it for a long time. And now we're finally getting ready to make a binary compatible release. But one of the things we want to do is keep source compatible. So if you remember the transition from Qt 3 to Qt 4, if you're from the old timers like us, if you remember how painful it was, that should not happen again this time. So we have a couple of features. We are really focusing on the graphics stack. You might have heard of QML, which is not C++. I actually don't program in QML, but then again, I don't do graphics either. I'm just the core guy. On my last visible class that I wrote was in a demo. It's called a text progress bar. So even the visible things I did was text. So yeah, I'm not going to do this, but it is a technology we're very much focused on. So I'm going to do the sales pitch here. If you want to learn more, you can go to the website. And those of you who are coming to developer days next week in Berlin, there will be a lot of sessions about it. The current state is that we have beta 1 out. It's what was released end of August. We're working feverishly to get the beta 2 out. So you see it's real soon now because it's ready, but sometimes we find a mistake. The last one was that we forgot configure.exe. And we want the final release hopefully before Christmas, so it's a Christmas gift for you and us. Otherwise, we'll have to in January. For Qt5, we want to do some more C++ 11. Mark, why don't you take this one?
Yeah. So as every other C++ developer, we are enthused and excited about C++ 11, and we see, as John always does much higher to tell, it's a completely new language. Of course, we want to make use of it. We want to learn that new language. We want to try it out. No, we can't. Right? We as developers think that C++ 89, massively 98 support, 89 would be even more costly. 98 support costs more because we all want to write numbers and outputs and not write all those funky types anymore. So that's actually a blog post of mine. So as every C++ developer, we want to use the new standard. We want to forget as soon as possible that there was a C++ 98 or 03, the bug fix release, and we want to move on to the new things, but we can't, because while we are an open source project now, we also have a large base of commercial customers. So we need to maintain compatibility. Right? We don't want, as Thiago said, we don't want to have another Qt3 to 4 port where we change all kinds of things. So we dropped a few compilers, upped the requirement to compile Qt to needs to be standard conformant, but with the old standard. So Qt4 still supported some stuff like MSDC6 and GCC 295.
I think it was 3.3. But the most problematic case was that the default compiler in Solaris is still not compatible with C++ 98, so you can't use some of the standard library features.
So we can't just use the new features. We have this challenge: how can we make use of the features for us and for customers that use C++? We'll talk about all the different modes in which you can combine stuff in a second. How can we do this while still supporting C++ 98? So what have we done in Qt5? The one that is supposed to be released this year still. We already added a lot of C++ 11 stuff, but in certain points, right? Not across the whole libraries. So we added some const expression, we added some move constructors. We saw that we couldn't add move constructors to certain classes. We're investigating that. And so you will see that we will use all these features, but not across the board. Not just because we're lacking time and experience to do so. And now the focus is on stability and getting the release out and playing around with C++ 11 features and possibly breaking C++ 98 compilers on the way is frowned upon, let's say. So there's lots of C++ 11 stuff left to do for 5.1. So by the time we have a meeting C++ in 2013, we can probably report on further progress there. One thing that I want to mention, because it's written here, it's interesting from a technical point of view. In C++ 11, constructors that can only be called with more than one argument can now participate in implicit conversions. Because if you write brace initializers and you pass them to a function, that is a multi-argument pack, a tuple, even though it's not a standard tuple, that can invoke any constructor, not just those with one argument. And just as you can mark single argument constructors explicit to avoid implicit conversions, so you have to do in C++ 11 with multi-arguments. And because whenever you start doing this, you have to explain why you're doing this. It's a slower process.
So one of our challenges, one of the things we have is we have this complex matrix here of what we want to support. We need Qt to continue compiling on C++ 98. So like Marc said, and like I said before, we have a large user base that cannot upgrade their compiler for whatever reason. So they're stuck for choices they have, they cannot change their compiler to enable C++ 11. Therefore, we need to continue compiling for the time being in C++ 98 mode. But we do want to use more of the features. We do want to, if possible, because it makes our lives easier, because it improves code. That's why it was done. So something that was said today in the keynote was the objective of C++11 was to improve the way that library writers, framework developers write code. We do want to make use of those features. Some of them are very, very useful for us. So we do want to compile Qt in C++98 code if possible. And we do want to let people use in their application C++98. But we cannot force this on them because, I don't know, maybe you do have the old use of auto in your code. By the way, can anybody guess how many users of the old style auto there was in Qt code? Zero. Do you know how many there was on the Windows code? One. We talked to an expert and they said, yes, we found one. Yeah, just get rid of it. Also, it was that keyword where the only place you could use it, you knew that it was useless because it was already flooded. So we do want to be in this corner. So by the way, whenever you see a 2x2 graph, you want to be one of the corners, right? If it's a graph, it's usually on the top. This is a matrix, it's on the bottom. And we like C++, so this is a plus corner. But our challenge is, let me get to how we try to solve the problem. So we do enable C++11 automatically. So if our Go system detects that your compiler has C++11 support, it will enable automatically. I don't think we even added an option to turn it off. Minus no C++11. No, I don't think so. We just enable it automatically because it improves the code generation. One of the features I'm going to talk about is exactly that. We've been asking for a long time, and the standard came up with it. But like I said, we need to build in C++98. The biggest challenge that we have is the library API. Because we want to maintain the compatibility. We've done it for 7 years with Qt4, and we need to continue for a while. But the biggest problem we have is whether the code compiled in C++98 is compatible with C++11. So you have the application compiled in 98 into C++11, which must work. The other way around as well. And then you have the permutation. You have the code that's compiled with one version of Qt, and then it runs on the system with another build of Qt, same version. It must also work. So this is a challenge that we have. The way we can do this is when we do want to use C++11 features in our code base, we must do it with a fallback. So we must work in C++98 mode as well, or it's a new feature. Or we can provide an line code. So if it's in a header, if it's something that is compiled into your application, not into Qt, then we can provide it. Another thing we've been doing is, I've been pushing people for, like what Mark said, C++98 should cost more. So we're adding new features which are only accessible in C++11 mode. This is to make you, our users, talk to your compiler friends and say, I want C++11. Right? Because you get new features, you get new functionality, you get performance improvements. There's a challenge within lines as well. And if you go down to the nitty-gritty details, for example, Microsoft Visual Studio and DLLs on Windows, it has this nasty habit of compiling all of the lines, even if they're in headers, right? It just compiles all of the lines from the class into the DLL. And then when it's trying to use them, it doesn't inline them, it just calls the one that should be in the DLL. So we have this problem that we need to compile everything. Fortunately, Microsoft doesn't allow us to disable C++11, so problem solved on that end. But it should just show up on other features. How we've been doing is that we actually created a bunch of macros. We looked at most of the standard definitions from the C++11. So in the morning, we had this very big list of new features that changed in C++. We chose the most important of them, the ones that felt like we might ever use them in the future. And I created a list and put it into the paper so that we remember which ones they are. And we try to detect them. So for example, the code says if GCC is version 4.7, it enables these features. The patch I was just working on before coming on the stage was like, I was looking at the GCC 4.8 page, and they say they support now attributes. What was it? I have it first. Let me show you this. Here it is. Where is it? So if you go to GCC's website, it says here they now support attributes, aligners, and inheritance constructors. So the idea was like, yeah, if it's GCC 4.8, define these things. Anyway, so going back to the presentation. For example, we did compile initializer this. So this is what you're going to see in your code, for example. You see, if it is defined, then we add this feature. And like I said, this is in a header. This is a template function, right? And it's in line. So we're allowed to do this. It's a new function. It's available in C++ 11 only. So if your compiler has C++ 11, you can use initializer lists with QList, with QVector, and the other ones. Was it that in this feature? Was it? If you don't have C++ 11, you have to use your own way to initialize this. Another thing we did then was macros for unconditional use. It gets tedious when you have if-thats for everything. And we do want to use in a couple of places when it's available, but when it's not available, it's no harm not to add it. The context declaration, for example, is a very good one. If it's in C++ 98 mode, it expands to nothing, and this function is already in line. If it is in C++ 11 mode with context support, it will declare it correctly. Those other examples there are similar ones. So, for example, the new no except attribute, if it's present, if it's compiler supports it, we use it, which means to the caller, no exceptions will be thrown. The caller doesn't have to do anything. But if it is the C++ 98 mode, it expands to nothing. Because instead of expanding to the old special exception specification, it meant more overhead. So we just do these things to do that. An example there is another align of. GCC has supported align of for some time. So that map is available in C++ 98 mode as well. But it's not in C++ 11 mode. But you need to be careful because some compilers don't support either. So unfortunately, that one needs to be checked.
Oh, we have a library implementation.
Oh yes, we have a library implementation now. So for Qt5 do this one. And then we start to build up. So one of the things I really, really liked that we did with C++ 11 and Qt5 was the QString visual macro. So you have QString, you have Q1 string, right? We added this new one, it's a macro, it's not a class actually. What it does is that it takes the text you write, the string literal, and it uses the compiler Unicode support to make UTF-16, which is the data that QString uses. And with some tricks behind it by using a lambda, it gets into read-only memory into the object. So this is exactly why we need to compile to C++ 11. Because the moment that we start using this macro, we reduce initialization time because the strings are now read-only. We don't have to do memory allocation. It's already there. So we get the access to the UTF-16 memory created, no memory allocation. This returns a QString, which is a pointer to the internal memory done. Now, if you're running in C++ 98 mode, or you're running in a compiler that doesn't support Unicode strings or lambdas, it falls back to UTF-8. The net effect is that you enforce that your code is actually using UTF-8, the source code encoding. This is a pet peeve of mine that the standard committee forgot to define the encoding of the source code.
Well, that's it's implementation.
It's implementation defined, which means that you do whatever. Unfortunately, that means that whenever I might, this is a Linux system, right? I have UTF-8, and somebody who's using Windows is usually coding on the local encoding of that system. So whenever he types my middle name, which is Jose, and has a non, you have the term, you have emails all over the place, right? So you know this problem. The fact is that their file doesn't compile for me because the encoding is different. So this is a pet peeve of mine that this should have been specified as UTF-8. But we have a lot of others. Just example of the no throw. Like I said, we have the no except. The no except means that this function doesn't throw. However, Microsoft Visual Studio's support for no throw in C++98 was non-standard. It was actually the behavior that we wanted in C++, the C++11 behavior. So what we decided was, we actually want to use this in Visual Studio. Even if you're compiling in an older version that doesn't have the new no except support. So what we did is that we have two macros. One that says, yes, this is actually a no except. Or one that says, if it is a no except, use it. If it is Visual Studio, use it. Otherwise, do nothing. So this is how we're building upon. So this is more about semantics and making features on top of it.
Another example for that would be Qt5 final, which is final, which the C++ compiler supported, and under MSVC compilers, it's C under all of those. Because the semantics I was saying is just a different keyword. And here, why do we use Qt no throw? Why don't we use Qt no except and back it up with no throw under MSVC? Because they are slightly different semantics. So no except function is allowed to throw, but it will invoke standard terminate if it does. Throw, empty throw specification, if you look at the documentation for Visual Studio, that says it's undefined behavior. So we use Qt no throw if we can prove as programmers that it cannot throw, like swap member functions, which throw, which literally cannot throw. And we use Qt no except only when we want to express that we don't want that function to throw. Like when we're in the logging and we produce a Qfatal and we think some logging messages, we want to avoid if we get memory allocation out of that. We don't want the exception to throw out of our logging framework. So we say there, it's acceptable if the application crashes, which is what some terminate does. But we need the exact C++11 function because we want to standard terminate and not do something undefined.
That's good, but we also have the problem that some language, some new functionality in C++11 we cannot access at all. There are two cases here. One is that in some new constructs, it's just not worth it. Take the example of the new range 4. By the way, that is implementing our old Qt4 so we're happy that this time came up with something we had. I understand you're working on reflection and mock. Hey, yay! Point is, to use the new range 4, usually we have to have the fallback code, which is equivalent. And since we would have if that, use this, else, use that, it becomes unusable. So better just not use it. The other kind are the standard libraries. Well, some of them would really like to use, like standard enable it, standard remove ref, standard move, standard forward. The only problem is that the libraries do not provide us with a define or something that we can use to detect whether it's available or not. So we end up having to do everything. So if you're, by the way, working on the comments here, you're one of the library writers, the implementation defines here, please add the define so we can detect and use the feature properly. This also means that some language constructs that require library features, we cannot access either. So take the example of 2 slides ago, the initializer lists. The compiler might support it, but if the library implementation doesn't, we can't use it because it's missing a declaration. This is common in embedded systems. So we were working with the BlackBerry people or outside the work at Qt5. And what they do is that they're using Qt5, which supports the feature. But they replace the library with an embedded version, which is smaller, and it's missing the feature. So we had to add another check for that one.
Windows C is the same problem. If you have worked on Windows C, you know that you get basically the current compiler, but very old test still on the SDK.
So it hasn't been a lot of problems. We run into compiler files. And since this is all new code here, I mean, every year I find one or two compiler files on GCC. Marc Mutz doing something similar as well. And we're stressing the new C++ 11 implementation. And sometimes they have been behaved differently. The standard itself is not without bugs, but sometimes they're implementing different versions, earlier implementations, incomplete implementations. So we have a problem doing that. And sometimes it's just difficult because it goes everywhere. Mark's going to talk about that. What I'd like to do now is just show some of the conclusions we came to while working with you, while you are doing this effort. First of them is atomics. We have had atomics in Qt since 2005, since 4.0, and we have had the API, which is just like standard atomics, since 4.4. And how did we do that? We actually wrote a lot of assembly code. On compilers that support inline assembly, it's using inline assembly. When it doesn't, it actually goes into a .s elsewhere. And then there's the generic implementation, which is horribly slow in performance, so it's not allowed to use. But it helps when you're trying to port Qt on your platform. So you turn that on, make sure it works more or less, and then you find a hacker who understands assembly and writes it. We would love to use standard atomic. And it appeared in GCC 4.6, for example, the new library, they had it. So I started using it. And I work for Intel. I actually like the assembly. I read the assembly and realized our code is generated better. What happened was that it was using full barriers everywhere. It didn't have relaxed trial or release. It wasn't implementing the full standard. So our code is still generated better. Worse than that, actually, I noticed that the ARM code, it was using blocks for everything. Even though the processor supported the proper atomics, it wasn't using them because the implementation was incomplete. So for the time being, we'll just keep our assembly. We'll have to keep maintaining it.
Yeah, and that is a problem because we expect that soonish compilers will start breaking our applications, just like they did before. Who remembers that bug where in GCC, in the Linux kernel, it clobbered a spin block when it was only supposed to write to an adjacent bit field? That was one thing. Another one was where it would optimize overflow check out of point arithmetic, thereby introducing a security hole into the kernel. It's always the programmer's fault because the programmer is there violating the contract, and the contract is the standard. And the compiler adheres to the contract, and of course, compilers, as the GCC people so nicely say, don't compete on security, they compete on performance. So when they optimize, they draw out all the trades that they can. Right? And it's therefore important to have this contract, this standard that says what the compiler can do, but also what we as deep programmers need to do. One of the important things for me, the most important thing in C++ 11 is the new memory. Because for the first time it gives us a contract, actually a correct contract.
I think I
lots
have
of
from
contracts,
side.
Java and stuff like that, they're all wrong. For the first time we have what we currently believe to be a correct memory model. Java has the same now. And it's the result of 5 years or so of research when it comes to
C11 has the same memory model now.
C11 too. And we better adhere to it because it doesn't only restrict the compiler, it also allows it to do more things. And once the compilers start to implement the memory model, which none have,
Sorry, we didn't trust the account.
4.7, yeah, whether correctly or not is the other question. This is one of the hardest things to do because it reaches into all kinds of things that the compiler apparently, or compiler writers can't tell any details. But it's one of the missing features that every compiler so far had in 4.7 probably has. It's the first to have it. And maybe 4.9 will then start optimizing in those gray areas where we compilers, where we programmers don't cannot rely on our intuition. Like our intuition is basically sequential consistency. Leslie Lambert defined that in the 70s, and that's what we've been using so far. The C++11 memory model is slightly different. And one of the things is that in order to have sequential consistency, so to have this simple interweaving of blocks of code from different threads, and by analyzing all the different interweavings, all the possible interweavings, we get the result set, all the possible results. That's the model that we've been using to test mentally, analyzing threads, multi-threaded systems so far. In order to get that back, because compiler writers and especially Intel break that to make our programs run faster. In order to get that back, we need to avoid having databases. Databases are defined very strictly in the standard and in a way that allows me as a programmer to quite easily check whether I'm having a database. And one of the important things is now that we have this window of we have the contract, we know what the contract will be, but none of the compilers yet takes advantage of the new freedom that the standard gives it. We need to use that window of opportunity to fix the data races in our, especially in applications, especially in the libraries. And that involves moving volatile and using atomics, even though our atomic operations library will have the same problem that volatile qualified things will have. When the compiler sees them, it doesn't associate them with multi-threading, because the standard says it doesn't have to. But by using our API, even though it has the same problems, once a compiler will implement the API, the memory model, we can have a central place where to fix our implementation. Yeah. So this is one important thing, and it's also something that kind of have to transform if you want to fix it. Because there's still this old model politics in the heads. Move constructors, another area that we've been working on. Looks deceptively simple.
That's why I need to
most of you probably have been on the talk, at least if you're speaking ones, that introduced this. So, but we kind of hit areas where we have member variables of classes that have a move constructor. And when we use those member variables, in our case it's smart pointers, in a class, we cannot have the move constructors of the outer class inline, because it's when the compiler, GCC, tries to call the member functions destructive. So that is probably a GCC part. We need to investigate that further. But that means that because a few versions ago, we switched all our implicitly shared classes, our copy and write classes, from having naked data pointers to smart pointers. We now have the problem that it's hard for us to add move semantics to all these classes, and especially those classes would benefit from it. Yeah, and apart from that problem, it's also a huge amount of work. You basically need to touch all the classes, you need to touch the collections that we have in Q, QVector, QList. They all need to be made movable. They all need to be to have the new API errors. And so work is progressing slowly, and we can only expect it to be finished by 5.1 and not 5.0. We also had some fun with const expression. If you want to play around with const expression, don't use GCC. GCC is way too relaxed about this. Except reinterpret casts and all kinds of funky things. At some point, it even allowed us to add const expression in front of a Q byte array constructor, which is not possible because the destructor is not trivial. You can only have literal types with const expression constructors when the type of size of the trivial destructor. Yeah, and we actually had to go back when Clang implemented const expression. We had to go into the code and back out some of the changes that we did, basically on the test from GCC.
Yeah, sure. So just like you were saying, we are going to find bugs. We're going to find bugs in implementation because they were never exercised by a properly strict compiler. So on Windows, Microsoft Visual Studio is kind of behind, lagging behind some of the other ones. So the features end up not being tested there. We have to consider, do we add the const expression with the other features to the Windows code, or do we wait until Visual Studio supports this so we figure out this is the correct thing? But even then, we can't make much of a choice. So just like you were saying, the const expression case, we wrote it, and imagine that we have released the code, and it's working for everybody today with compilers of this year, but then it comes to 2013 with the new versions, the user upgrades, it breaks. Or worse, the user downgrades. Sometimes that happens, and we never end up testing a couple of particular versions. So they tend to show up every now and then. You have to figure this out, but to be ready for them. What do we want to do now? Well, finish what we started. The work on loop semantics, we finished up one. We like to play with compiler features, just like I said, I was playing with Qt 4.8. And I also realized that they added this standard equals C++ 1y, not 1x, 1y. Yeah. So we can't use the can't 0x anymore, so 1y, targeted to 2017, but they haven't implemented one new feature yet, right now. So this is the kind of stuff I want to play with. Is this interesting for us? Can we do anything with it? Can we improve the code with it? I was expecting for a long time the user-defined literal so that I could use it and implement new things. When it finally came and I had the option of playing with it, debugging code, writing it, and seeing how far I could go, unfortunately my hopes were dashed and I couldn't do what I wanted. That's where QString literal actually came from.
Yeah, so template export control is very interesting for us because we have, of course, lots of containers, and most of these containers are instantiated inside Q already. Like QString list is inheriting QList of QString. So by using template export control, we forbid the compiler in the header to instantiate particular instantiations of the container class, like don't instantiate QList of QString or QList of QVector of QString or whatever. And that should speed up compilation of applications. We don't know by how much. So we need to do this across all the collections, so we can see how much it actually impacts. Again, focus on stability right now, so it hasn't been done. But that's something I want to play with. Another thing that I want to play with is Boost can do it, so why can't we? Standard library detection. It's much harder because you need to actually look into into Boost or into the library headers to find certain defines that are not always two-bar version, but something weird. But you can detect standard libraries, and that's something we're doing wrong now. We treat the compiler and the standard library that comes with it equally, and we run into problems on embedded systems like this. So this is something that we want to work on, I in particular. And of course, play with compiler features is always high on our list because, well, we're paid for it. We also want to have fun. Yeah, conclusions. So as I stressed in the beginning, and as everyone like you C++ programmers feel the same way, I know, we all want to use that ASAP in production right now. So the best thing for us as developers, we would like to put the old version in maintenance mode, so people with older compilers still use Qt4, and in Qt5 we would require C++11 support. Unfortunately, we couldn't ship Qt5 because no compiler supports C++11 completely yet. And we also cannot really afford that because we want people to change from Qt4 to Qt5. We don't want to hinder them because we are an open source project and we have limited manpower, so we would like to minimize the number of versions that we have to maintain concurrently. So we don't want the Q4 picture where the porting was so hard that we still have Q3 people sitting now that we have Q5 on the old code bases that are imported. So if we can't afford that, what we want, we need to target both C++98 and 11 simultaneously, and this is what we've been doing and describing. In any case, it's important to familiarize yourself with that memory model, because it's not just a feature that you can tick off, it's something that you have to scan the whole code for. Hellbrine and this analyzer XE, it's called, talked before, should help, but they also need to be updated. Hopefully.
Is the D-Tune amplifier XE?
Thank you.
Yeah,
Oh, sorry, you were. We still chosen.
It's the same people who call the compiler the composer XE.
Yeah, so some conclusions about when targeting both C++11 and 98 simultaneously. Determine if you can which compiler versions you require. So we said we don't require GCC 295 anymore, or MSVC 6. And then focus on the C++11 features that require no client code changes, like for example const expression. Simple recompilation of the program will turn Qt align left, high, Qt align center into a compile time constant. Before it was a function call, because we're overloading the OR operator for our flags to have type-safe enums. So that if you OR together two enums, you get enum back, and not an int. Then hide the difference in macros, so you don't have large if-def blocks. Sometimes they're not avoidable. If you want to have a particular nasty example, look into qvariant underscore p.h. We have 3 versions for detecting whether a function has a null, is null method. That's quite fun. And then don't be like we are. Resist not invented here syndrome. Don't try to make these detection macros yourself. Boost has done them, Qt has done them. It's annoying. It's not fun. So if you can accept a Qt or Boost dependency, I guess other libraries have done the same because we're C++11 and we always start with our new string class. But try to avoid that. Use it, but avoid it. And then try to keep binary compatibility between the versions that are compiled with C++11 and C++98, because it will allow the customers, if you have some, to decide themselves. Or if you don't, and you have it in-house, you allow every platform to progress independently and every developer to progress independently. So they can use C++11 on development machines, to use Qt override to see when your overridden virtual functions can actually override something, or static class, static asserts that are basically development tools for you as a developer. And the production builds still go out with the old proven compiler, but you don't have these checks then. Want to add something?
No, the world of nations starts to get constrained.
Yeah. So we take some questions.
Let's get the questions in the audience. If you don't have any questions, of course, we are able to answer questions afterwards. Mark is stayed out, so he probably has booth Qt and is going to be outside having to talk to everybody who comes to his booth. So I'm, on the other hand, we're going to be watching the sessions, but if you run into me in the hall, you can talk to me. I'm available by email, actually quite active. Anybody have a question here? No? Then thank you very much. Oh, sorry, now there's a question.
What?
Yeah. There's a transition to Qt5 now, and also to C++11 as you have talked about in your talk. And also you talked about all these container classes, which are kind of designed in an object-oriented style, and you have your own QString class. Isn't it now the time to converge more on the standard type of design on those classes and to take those old classes out?
Thank you for the question. It's a very good question. And I'll answer that and why we don't use boost classes as well. We had finally required C++98. So up until Qt4, it was possible to compile Qt and Qt code with almost no standard library handler at all. You required like include U and a few others. Now we require at least that you have that. It's no longer an option to compile without C++98. So we could, in theory, use standard list or standard vector or standard something else. There are two reasons why we don't. Actually, three reasons why we don't. One is that we are not sure the performance quality of them all. Usually they're good. Usually they're good because they come from the compiler team who knows exactly how the compilers work and they create the proper code for it. But sometimes they replace. So on embedded systems, sometimes they replace and the code quality is worse. The other two reasons are that our class is a reference counter. This is something that we prefer. We prefer the way that we've done because it actually helps the way that some of our guys, some of our customers who are using the code are not as good as developer most of you guys are. So they end up doing wrong things that cause more memory consumption. And finally, it is the API. So the keynote speaker said that he thinks the STL is elegant. I don't like the underscores in the names. I think that pushback doesn't tell me if it goes in the beginning or the end. And so he's talking for himself. But the point is, we want consistency in the API. And finally, for Boost, why don't we use some of the Boost classes? Boost doesn't maintain binary compatibility. And that's underscores. So the binary compatibility is the argument, not the underscores.
Source compatibility is also an argument why we don't drop Qvector, because people are writing Qvector right now, because that's all they have in, well, either they write Qvector or standard vector. But they expect Qvector to be there. It's mentioned in the API. So if you want to maintain source compatibility between 4 and 5, we need to keep that name. We can't just make it typed F because we have our own names for size and with empty, so empty and append. So
the only solution that we could have is to raised to vector, wrapping around standard vector, adding the reference implementation, the reference count implementation. It was possible. We just didn't have the time to do it with manpower. So we prefer to just continue and work on other things to Qt5.
But that's a big team. You have to maintain it. You have to write documentation. You have to add the new semantics. That's a big team. You have to add. You know it.
I know. The thing is, it didn't seem to be that much of a task in the beginning. But of course, the documentation is already written.
Yeah, but we have to.
Now we need to do. I know. The problem is, it was a decision that was made, right? And of course, at the time, it looked like the right decision. I'm not saying that it is. I think today it's wrong. But the fact is, today we cannot change it anymore. Not for 5. So when 6.0 was going to come out, I don't know when. I hope it's not in the next 2 years. We can revisit the issue. Okay, I think we're over time. So let us know outside if you have more questions. Thank you very much for coming.